Hi, this is Pablo from the C# Academy. In this tutorial, we are creating a coding tracker. This application should log your coding time using CRUD operations. It's a console application where we use the terminal as an user interface. We validate the data from the user, process that data with business logic written in C# and interact with an Sqlite database using SQL in our controller. This tutorial is the second of a series of projects designed to get you started with C# in a very practical way. It's very similar to our first habit tracker project, but introduces a few concepts such as separation of concerns, dealing with date and duration, and using external libraries. This is not an absolute beginner tutorial, so you should have a basic understanding of C#, and you also need the ASP.NET environment installed in your computer. Having watched the first tutorial helps, but it's not essential. But do keep in mind that this tutorial is part of a series of progressive projects. So let's get started. First of all, we need to open Visual Studio Code in the folder that we want for our project. If you haven't created a folder yet, you can click on Open Folder and create a new folder in this window. Now if you click Open, Visual Studio Code will reload. And now we are working in the folder that we want. Now let's open the terminal so we can create our project from the command line. So now your integrated terminal is open. And let's type .NET new console -- name and the name of our project. Once the project is created, we're going to see program.cs file and codingtracker.csproj. In program.cs, we have the main method, that's the starting point of our application, and the csproj is where we have configuration information about the application. We also have a couple of folders related to building and debugging the application, bin and obj folders, and the same with .VSCode, where we'll hold information about launching our application. And inside .VSCode, we have a launch.json. Let's change the console property from internal console to external terminal. That means that whenever we launch this app, a terminal will open outside Visual Studio, and the app won't run in debug console or integrated terminal. Now, before we continue, let's clean things up a little bit. I want to hide the folders that I'm not using, so I can do that by going to Code, Preferences, and Settings. And if we type hide, we can go straight to the files exclude area and add the patterns that we want. So we're doing ***/ bin, and the same with obj, and the folders have disappeared. If you need those folders again, you can always undo that action. But now let's get to work. Let's start coding. The first thing that we need to do is to store our connection string somewhere. So we're creating a string, and if you watch the first tutorial, we hard-coded the string in the class, but that's not good practice. That's not very safe for your data. And the connection string is very sensitive information for your company. So let's store it somewhere else. We're going to use the configuration manager package. And you can add packages in Visual Studio Code by pressing Command-Shift-P if you're using a Mac and Ctrl-Shift-P if you are on Windows, choosing Add Package, and finding the name of your package. In this situation, system.configuration.configuration manager. And don't forget to choose the same version as the .NET version that you have installed on your computer. Don't forget to click on Restore every time you add a NuGet package to resolve your dependencies. And then obviously we need to add a using statement for the configuration manager. And you can do that by clicking on the light bulb and finding your package. Now let's create a class called Database Manager. And you can do that by declaring it first and using Visual Studio Code shortcuts to create the class in a new file. And the access modifier for this class is internal, which is the default when you create classes using the shortcut. And that means that this class can only be used inside this assembly, which is fine for this project. Now inside the main method, let's call a method called databasemanager.createTable. We get a compiler error because main method is a static method. So let's create a database manager object inside the main method and declare the connection string static so it can be used from static methods. But before continuing, we need to create a configuration file. The configuration manager reads the properties from a configuration file, and that file has an XML format. All you need to do is pass this code, making sure that you have a key for the connection string, and the connection string follows that exact format, otherwise you'll run into errors. And again, with the help of the light bulb, let's generate a create table method inside the database manager class. Now let's create a connection to the database to create a table. So we're creating an instance of the Sqlite connection class, and we are wrapping it in a using statement. That ensures that once the class is used, it's disposed of. If that doesn't happen, every time we open a new connection, it's going to slow down our application and our computer. Then we need to open the connection and create the SQL command. The SQL command we're creating here is quite self-explanatory. We have a create table, if it doesn't exist, with the name of the table. My table will be called coding, and we'll have three properties: ID, date, and duration. Notice that the types are slightly different from SQL if you have worked with something like SQL Server before. So the ID is an integer, which usually we write int if you're working with SQL Server. The date we're going to store as a string or in SQLite text. In SQL Server that would be a varchar, and the same with duration. Once the command is created, we need to execute it, and for that we're going to use the execute non-query method. And that method means that we don't want the table to return any values. We're not asking questions from the database. And then we need to close the connection. Now the C# compiler is complaining about the SQLite connection object. So we need to add a NuGet package for that. We're also adding two properties to the ID property. The first is primary key, which means that this property will be the identifier for each row, and auto increment, which means that every time we add a record to the table, the ID will increment itself. So let's add the Microsoft.data.sqlite using the same version as your .NET version, and then restore our dependencies. Notice that it was recorded, it was registered in our CS_proj file. And now we can add a using statement by clicking on the light bulb. Now let's run the application to see if our command works. And things are looking good. Looks like we created the db.sqlite file. If you right-click on the file, you can click on Open Database, go to Sqlite Explorer, and see if the table was created. And it looks like we created our table successfully. Before we continue, let's refactor things a little bit. When we call the create command method, we are creating an instance of the SQL command object. And that's also an unmanaged resource, and we need to dispose of it. So we need to wrap it also in a using statement. Notice that I also eliminated the connection.close. Now that we dealt with creating the table, let's start getting the user input. So I'm creating a new class called getUserInput, and I'm using the help of the light bulb again to generate that class in a different file. And it's also going to be an internal class. And then I'm creating the main menu method. In the main menu method, we're going to create a loop to collect the user's input. And for that, we are creating a Boolean. The Boolean will be the condition for the loop to keep running. So while the close app Boolean is false, the loop will keep running. Here I wrote all the commands that I want to show to the user. And I added some separation between some lines with the \n notation, just to keep things a little bit more organized. Then I'm going to store the user's input in a string called command input. For that, I'm using console.readLine. When our code reaches that line, we're going to wait for the user's input. Then I'm going to add some validation. So I'm creating another while loop, and the condition for that loop to keep running is that the string is null or empty. If that happens, we're printing an error message and asking for the input again. After that comes a switch statement, and that depends on the command input. So if the users type 0 to 4, we have set actions. And in case they type anything else, the default case will take care of it and break out of the switch statement. Also notice that in case the user types 0, we have environment.exit, which means that the application will close. So let's comment out all of the actions except for the process add. So when the users type 2, we're going into the process add. So let's see what that method does. The idea behind the process methods, and we're going to have one process method for each operation, is to do any processing of the data, anything that needs to be done with that data, any calculation or validation gets done before the data actually gets sent to the database. We don't want to do any processing of that data inside the methods that will interact with the database. Those methods will be created in the controller later in this tutorial. First, we're going to collect the date from the user. And for that, we're going to create a getDateInput method. Inside that method, we're going to print a message asking for the exact format of the date. And we have to be very specific about that format. We don't want to allow the users to insert the date with any other format to make life a little bit easier for us. And using console.readLine, we're storing the input in a date input string. If that input equals 0, we are sending the user back to the main menu. Then we need some validation. For that, we are using datetime.tryParseExact and passing a bunch of arguments. The first one is the string that we want to check, then the format. So we need to make sure that the user is typing that exact format, and adding information about the culture, remembering that dates vary depending on the language and the country. That method returns a Boolean, and the exclamation mark in front of the method means that if the users input a format different than the asked format, the loop will keep running. Inside the loop, we print an error message and collect the input again. And after that, we want to return the processed string. That's going to be the date input. Now let's run the application in debug mode so we can step into the code. If you haven't used the debugger before, this is a very useful tool for debugging your application and understanding how it works. You can step into each line of your code. So here I added a breakpoint to line 63. So that's the red dot just by the number 63. And I have my application running. Once I type 2, that breakpoint will be hit. That's the yellow arrow around the breakpoint, or the red dot. And then we can step into the code by pressing the down arrow. So we reached the console.read line, which means that we are waiting for the user input. So let's try to input something. Let's see what happens when we try to input an invalid date, the 30th of February. In this situation, we checked if the date input was 0, and that check failed, so that means that we're not calling the main menu. And then we can verify our date and see what happens when we reach the loop. So the datetime.tryParseExec returned false. That means that we reached the inside of the loop. We printed the message and we're asking for the user's input again. Now let's try to input a valid date, 25th of February. But this time, tryParseExec returned true. That means that we don't reach the inside of the loop. And then we return our date input finally. Back into the process add method, we also need a variable for the duration. And for that, we're going to create a getDurationInput method. This method will be very similar to the getDateInput method. First, we need to print the message saying exactly what we want with the exact format. Then we're going to collect the date by using console.readLine, and we'll check if the input equals 0, which always means that the user will go back to the main menu. After that, we're going to add some validation. This time, we are using timespan.tryParseExec to check if the format matches the format that we want. If that's not the case, we print an error message and we get the user input again. And if that new input is 0, we send the user back to the main menu. I've also added validation to check if the duration is negative, but later I realized that the initial check already takes care of that, so you can skip that part and return the duration input. In the GitHub link for the repository for this tutorial, you're going to find the correct code without the validation for the negative duration. Now that we have both the date and the duration, we can create an object. And that coding object will be of the type coding. Let's generate a type for that. That's what we call the model for our data. So we created the coding class in a different file, and we're going to tell what the properties of that model are. So here we have three public properties. One is going to be an int, which is the ID, and then we have this string date and the string duration. Now remember, we don't need to collect the ID, because when we created the table, we declared that the ID is auto incremented. So that means that we don't need to pass an ID. We need to assign values to its properties, and the values will be equal the inputs. Now that we're able to get a user input and store it in an object, we need to send it to the database. And we're going to do that in a coding controller. In the coding controller, the method that will take care of adding a new record to the database is going to be called post. And that method will receive a coding object. So let's use our amazing coding generator to generate the coding controller. And here we're also going to need a connection string. We need to bring in the configuration manager using statement and create the post method. It will be void because we won't return anything, and we're passing the coding object as an argument. From here, we're going to follow the same pattern. We're creating a connection and a command, wrapping both of those in using statements. Then we are opening the connection, creating the command, and executing it. And the insert command is pretty much self-explanatory. We are inserting into our table. We're telling what columns we're going to insert values into and inserting those values with string interpolation. The values are the properties from the coding object. So now it's time to test our command. Let's run the application. And let's insert a value. To see if the value was inserted, let's check the database by right-clicking on the table and choosing Show Table, and we can see that the data was correctly inserted. Let's see if our validation is also working. So let's try to insert a record. Correct date and wrong duration. It doesn't let me. It tells me the duration is invalid and asks for a new duration input. Now let's add a get method. Through this method, we're going to retrieve information from the database. First, we need to create a list, and this list will be a list of coding objects. Then we repeat the same pattern. We are creating a connection object and a command object, both wrapped in using statements. And then we're creating a very simple query. Select everything from coding. Now we need to create a third using statement for the reader object. We also need to dispose of that. So let's see how we are reading the data. We have a conditional statement, if else, and if the reader that we created returns any rows, we're going to populate our list of coding. And if it doesn't, we'll print a message saying that no rows were found. Now to populate that list, we are looping through the reader. So we're looping through the rows of the reader. And for each row, we are adding a coding object to our coding list. Now we need to show the list to the user. So first, let's create some separation with a console.writeLine and a couple of spaces. And then we're going to create a different class called table visualization with a show table method that will be responsible for showing the data. So let's create that class with our code generator. And then let's create a method that's a little bit different than the ones that we've created so far. This method accepts a list of different types. When we say that we're accepting a list of T, that means that we accept a list of generic type, which allows us to pass different types of lists as an argument. Now, instead of trying to show the list ourselves, we're going to use an external library. And this library wasn't developed by Microsoft developers. It's a public library developed by an independent developer, and it helps us with the presentation of our tables. So let's add the NuGet package manager console table ext. And once that's done, let's create some separation with a couple of empty lines, and then bring in the code that will actually print the table. We are passing the table data into the from method. We're also adding a title, and then we're finally exporting and writing the line. And then a couple more empty lines just to keep things more organized. Going back to the main menu, let's make sure that the coding controller.get gets uncommented. Then let's run our application again. And type 1 to view the record. And as you can see, there's a nice presentation to our table now. Our next step will be to write code to deal with the delete method. Inside the process delete method, we need a few different things. First, we are showing the table so that users can grab the ID of the record that they want to delete. Then we are printing a message asking for the ID, and we are creating a loop for the validation. In this validation, we are checking if the ID is a number and if that number is higher than 0. And we're also checking for null or empty inputs. If any of these conditions isn't met, the block inside the loop will run and will print an error message and ask for the input again. After that, we are passing the input into an integer. We're checking if the input is 0, and if it's 0, we send the user back to the main menu. And then we need to check if that ID exists, or if that row with that ID exists. And for that, we're going to create a new method in the controller. We're going to pass the ID to that method. So we generated a new method called getById. And in that method, we are following the same pattern as before. We're creating a connection, we're creating a command, wrapping both of them in using statements, and then we are reading the data just like we did in the get method. We don't need the reader.close since the using statement takes care of that for us. Now our getById method is returning a coding object. And if the database doesn't return any rows, we're still going to return an object. And that object will have no properties and the ID of 0. And that's going to be the condition for our loop. If the ID is 0, that means that we return no rows. That means that the delete method didn't work, which means there are no rows with that ID. If that's the case, we print an error message, get the user input again, validate the data, and call the getById method again to check if a row with that ID exists. Here I have to change the return type of getById from object to coding. When it was auto-generated, it created an object return type. So now we are able to access the ID from that object. Once all of that is done, we can finally call the delete method in the coding controller, which we still have to create, and we will handle the deleting of the method against the database. So here we are creating the delete method, and no surprise, it starts with two using statements, one for the connection and one for the command. We open the connection. Then we create the delete command, which is fairly straightforward using string interpolation. We execute the command, which doesn't return any values, and then we print a success message. So let's run the app again. The menu is open. Let's try to delete a record. I tried an ID that doesn't exist and return the correct answer. But when I try to input a string instead of a number for the ID, the application broke. Let's see what happened. What happened was, inside the loop where I'm checking to see if a row with that ID exists, I didn't add the validation to check if the input was a number. Now, because I have so many things to do inside that loop, I made the decision to refactor, just print the message, and go back to the beginning of the method, since the code was so similar to the code inside the method. So in case there are no rows with that ID, we go back to the beginning of the delete method. So let's check the application again. I try to input a string and I got an error message. I'll try to input an ID that doesn't exist and I get the corresponding message. And then I try to delete a row that exists and everything works fine. The next step is to handle the update of records. So let's uncomment the process update. Let's create that method. And in this method, we're also going to start by showing the table that we have currently, so that the users are able to pick the ID of the row they wanted to update. Then we print the message asking for the input. We store the input in a variable and check if the input is a number, if it's null or empty, and if it's not negative. So these are the conditions for the loop to keep running. If any of these conditions isn't met, the loop keeps running. And inside the loop, we are printing a message and asking for the input again. And here, we also need to verify if the row with that ID exists. So again, we are using the getById method to verify. Then we are passing the input into a number. If that number is 0, we send the user back to the main menu. So I'm creating a loop that depends on the ID of the coding object. If that's 0, just like we did in the delete method, we print a message and go back to the beginning of the method. Now, if you have watched my previous tutorial, the habit tracker, in our update operation, we didn't give the user the chance to update just one property. And that's not very good practice. In case you have dozens of properties or hundreds of properties in an object, the users need to have the chance to change only what they want. And for that, we're going to create another loop, another menu where we're asking what the user wants to update. So in this menu, the user is going to pick the property that they want to change. And for that, they will type a letter that's associated with that property. So let's explain this part. It's a fair bit of code, but it's quite simple. In case the user types D, we're going to change the property of the current object, which was grabbed from the getById method. New value of that property will come from the getDateInput method, where the user will input the date. The same happens with the duration, and if the users type 0 or S, the Boolean updating, which is the condition for the update menu loop to keep running, changes to false. which means that we get out of that loop, update the record, and go back to the main menu. Now the update method in the coding controller has no surprises, the same using statements, open the connection, create the command, which is also pretty straightforward, and then execute the command. I print a success message, and that should be it. So let's test everything to see if it works. In the main menu, I'm choosing to update something, that I'm testing all the validation, record doesn't exist, string is not valid, negative is not valid. Now I'm trying to update the date, so the new date is going to be on the 18th, and it works. Now let's try to do the same thing for the duration, checking for string, negative, and negative duration, and none of that works. And when we try to input 12 minutes, it works. So that's it. The application is complete, but now I have a challenge for you. What would you do if you wanted to record two types of habits in the same application? So let's say you wanted to record not just your coding time, but also, let's say, your sleep, or your running time, or your commute time, or anything for that matter. What would be your solution? I would love to see what you come up with, and if you have questions about how to solve this challenge, please reach out and I'll be happy to help. Don't forget to subscribe if you like this video, and also join our beautiful Discord community in the link below. See you next time!